So again, if it applies, we are going to distribute. If distributive property is there, we will distribute. If not, we keep moving. All right? Our second step was going to be to combine like terms. And we're going to add something here. I'm going to add a phrase there. Combine like terms contained within the same size. That might seem a little weird, but I'll show you what I mean. All right, so we've got combined like terms. Then on our other paper we had, we're moving the variable at this point. This is back to our normal step 3. Isolate the term with the variable in it. And then we're going to be back to a solve the one step. So really we've got something going on in step 3 here. And like I said, this is going to be our hardest type of equation to solve. So you need to focus in. Yes, sir.
What is that more thing
With. That's a shorthand for with. Sorry. And if you go back and look, what's going to be different about these equations today? Well, they have variables on both sides. We have not seen that before. Go look at example 1. I have a 9a on the left-hand side of my equal sign, and I have a 4a on the right-hand side. All right, before we get going, I'm going to give you one more hint. Something that may help you. I'm going to require everybody at the beginning to do this. And if you prove to me that you don't necessarily have to do it, then I will let you stop. But you've got to be getting these correct before I make you stop doing this. You are going to draw a long vertical line under the equal sign. And I'll tell you why that's going to help you once we get started. So I know that's weird that Ms. Walters is having you do something like this, but I'll explain it, and I think I can even explain to you why you need it. All right, so we're going to start with number 1, an easy one. And the first thing I'm going to do is I'm going to draw my long line here. This is what I mean by draw a long vertical line underneath the equal sign. Everybody see that? Alright. It's not going to be a big deal for this problem because this problem is very basic compared to what we're going to be doing by the end of the day. But for now, what this does is it clearly identifies what I need to do when I need to combine or when I need to move. Okay? So there's a difference between combining terms and moving terms. If it's going from here to here, that's a move. Right? If it's going from here to here, that's a move. If it's just combining something over here, that's just combining. Is there anything to combine over here? Can I combine? No. This problem it doesn't really apply, but we're going to get in the habit. Is there anything to combine over here? No. But if we were combining, it would just stay on this one side. Okay? So we're not going to have step 1, or actually not even going to have step 2 for this one. But we're getting in this habit. This line is going to tell us, am I just combining a like term within a side, or am I moving? And we have to do something different depending on the answer to that question. So let's look. Do we have distributed? Yes or no? Do we have distribute?
No.
Do we have like terms within the same side?
No.
No. No like terms within the same side. Now, do we have like terms on opposite sides?
Yes.
Yes. So are we going to do a contained combine, or are we going to have to move?
Move.
We're going to move and look using opposite operations. Now here is where you have a choice. You have a choice. If you would like, you can say, you know what? I'm going to move my 9a, since it's the first term with the variable in it, I'm going to move it over here and join it with this 4a. Now, there's one thing I kind of don't like about that, because what operation am I going to use for this 9a? It's a plus 9a. What am I going to do, Eliza? I just want to move it over here. Well, it is a plus 9a. So I'm going to subtract 9a. 4a minus 9a is going to give me a negative a, right? Negative 5. But I could do that. Or what else could I do? I could take this 4a and say, no, I want all my variables on the other side. So I could take the 4a and move it over here. Either one, you have a choice. I am going to try to keep things positive where I can. And it doesn't really, since it doesn't matter which side the variable's on, I'm going to move this one because when I subtract 4a from both sides, I have a positive side of a. Okay? So y'all see what I'm doing? I've got a's over here, I've got a's over here. I need to get them together, but I'm having to move them across this line. So when I'm moving them across the line, I'm using opposite operations. So you may either subtract 9a from both sides and move it off this side, or subtract 4a. I'm going to subtract 4a. All right. So watch me do it. Because I am crossing over this line, a move requires opposite operations. So I'm left with, somebody tell me what I'm left with on the left-hand side. Caroline.
Negative 11. 5a plus 2.
And somebody tell me what I'm left with on the right side. L. Does that look like a solvable equation? Yes. At this point, the line doesn't really matter because you're solving a two-step equation. But somebody tell me, what is negative 18 minus 2? Milo, negative 20. So A equals negative 4. I did not show you the last step, but I'm just dividing both sides by 5. Any questions about example 1? Now I'm excited. Example 2 gets a little more interesting. Yes, go on.
Can you show the last?
Yes. Oh, certainly yes. Certainly yes. Okay, example 2, things get interesting. We're still going to start this way. Oh, what a bummer. My line is bowed. Bowed? Do y'all know what a bow? It's not a pretty line. Okay, so let's look.